Okay, hello Andre. I've determined to keep this short. Um, so the first question was just to change the colors on the tips, and so you add the struct, which I put in here, position and color, and then you put in the vertices, and then you have to change the input layout to do position and color, which matches up to the vertex semantics. Alright, so I think you saw that one. Second one, nope. Is the full triangles of color. And here they come. Alright, so yeah. And so you have 6 triangles, and here they all are, the same setup as last time with the colors, the position and colors, and everything, but all you do is you create 6 separate triangles, and then you wrap them, and then you give the indices for them. Instead of using 8 vertices last time, you have to use 18, 3 times 6 triangles. I think, yeah, this is the same, everything stays the same. Alright, next one is this one. This is where you switched the color and the position on the simple vertex struct. And so it's the same output, but here you see you have color and you have position switched. And so okay, so I did not switch them on the shader. What I did was I switched them on the input, and you have to, the most important thing though, the order of this doesn't matter, but you have to switch right here where the byte offset is to find them. So that's the most important thing that you had to change in the layout for, in the input element layout. Okay. So this one, really learned my shaders on this one. So we have that, and then we have the struct of simple vertex position and then the color number. And then you have your, for the constant buffer color. And so what you had to do was you had to put it in, you had to set the constant buffer, to the vertex shader. And here's my shader. You have vertex data, a position, and then an index. They keep the same semantics. You have your pixel data, position, and a color. And so the vertex data goes in to the vertex shader. So every vertex that is laid out right here, it's the same triangles, goes through here, and then it gets the position, and then it sets, so it creates a pixel data, sets the position to the position of the pixel data, and sets the color based on the index right here to the color of the pixel data. And then for the pixel shader, it just takes in the pixel data and sends it back out. And then you have a shader constant right here for the constant buffer. And I think why the pixel shader didn't matter and the vertex shader mattered was because of this input here. It had to know about the constant buffer going on because of this, because it's in its function. Alright, and so the further work you have, what's the difference between a constant buffer and a shader constant? A constant buffer is, this means constant buffer, and it's what holds the shader constant. The shader constants are right here, and so they're going to stay constant throughout the whole runtime and everything. And the constant buffer, you can like switch out different constant buffers, but you can't change the shader constants within them. I believe so. And then for the final thing with the smoke or the white, the reason why it's not affecting the screen is because the shader is only affected by only affects the inputted vertices that we input. So like all this stuff out here, we didn't do anything with it. It's just a background color. And so in here, but we change and we set up the vertices and indexes. Vertices and indexes. And so the shader only only affects these pixels in here. Okay, thank you. I'll see you later.